My name is Chris Frakes. I run our content team at Modern Treasury. Welcome to our Tech Talk on Ledgers. Today, we'll be talking to our Modern Treasury experts about how a central ledger can unlock new products and drive efficiency for companies. Let's start with introductions of our esteemed panelists, Koji Murase and Matt McNierney. Koji, let's start with you.
Hey everyone. Hey Chris. I'm Koji. I'm on the product team at Modern Treasury, and I joined the company a couple of years ago to launch our Ledgers product. Excited to talk with y'all today.
Hey, and I'm Matt McNierney. I'm the engineering manager on the Ledgers product. I've been working on this for the past year and a half.
Great. Koji, I'm wondering if we can start with you, and can you share a little bit about the origin story of Ledgers at Modern Treasury?
Of course. Today we want to talk about ledgering and closed loop systems in general, but I just want to give some context on why we know a little bit about this topic at Modern Treasury. For those who aren't familiar, at Modern Treasury, we're building the operating system for money. So that means we work with best-in-class software companies like Marqeta, Gusto, and Procore, and we help them think through and power their embedded payments products. So it's been a really amazing vantage point for seeing how the best companies build embedded finance products. And a couple of years ago, one of the things we noticed was that the best software companies build the same thing, which is a ledger. If you're building a financial product, you need a ledger to know what transactions took place. So that's why we launched our Ledgers product. And since we launched it, we've seen a really rapidly innovating and maturing ecosystem. And we've seen more companies start to understand not just what a ledger is, but why it's critical and that there's a right way to build it. So this is the really exciting thing that I want to talk about today, is the innovation around ledgers and how people are creatively using ledgers to power new innovative financial products.
Yeah, let's dig into that a bit more. The term ledger can apply to many different things. Can you clarify what you mean when we're talking about the Modern Treasury ledger and ledger databases and how that's different from a general ledger?
Most simply, a ledger is a database for financial transactions. So why is that different from other databases? Number one, financial data is really critical. You can't mess it up. So what would happen if we went into banks around the world and wiped out their ledgering data? It would be a huge problem, obviously. We wouldn't know who owns what. So it's important that we store that data in a very safe way. Another reason financial data is different from other data is if you look at a lot of fintech companies, you'll see that they build their ledger in pretty much the same way. No matter what the use case is, could be loans, marketplaces, wallets, we tend to see the same ledgering patterns across companies. And so the best practices for how you ledger for one company tend to apply to other companies as well.
I just want to touch a bit on the general ledger point. So companies have been using double entry accounting for centuries, and they've been using general ledgers for a long time as well, software that helps at the corporate level think through what are the assets and liabilities for the business. What's more of a new trend is using double entry accounting to actually power your applications. So that we've seen companies build and use have some similar features as general ledgers. So they're immutable. Any change you make to the ledger is going to be immutably recorded, and you can play back past states of the ledger. Also double entry, of course. So it's ensuring that every time you're writing a transaction to that ledger, we're balancing credits and debits. You can't create or destroy money. But there's some ways in which they're different. The first is performance. So these ledgers have to be optimized for high throughput ledgering. We're talking like thousands of transactions per second, potentially. And also, they need to be optimized for efficient reads. So that's a big reason why we see companies investing in these ledgers, is to get efficient aggregations. You want to be able to pull a balance for an asset account or liability account super quickly. And then next is concurrency controls. So at scale, you may have multiple threads writing to this database or multiple microservices writing to it. And you need to have some way of ensuring that the ledger is still consistent, even if transactions are written out of order. And so that's why a lot of them have some form of concurrency controls. Another thing that's different is how you actually architect the ledger. So a ledger database provides really simple primitives, and you have to take those primitives and apply them to your business. The way that you would design accounts in a general ledger is pretty different than how you would do it in an application ledger. A general ledger is typically thinking about big buckets of money. So your accounts payable or accounts receivable. An application ledger, we typically advise companies to make the accounts as granular as possible. So what's the smallest balance that you might want to show in your app or that you might want to track when you're doing cash recon? So you'll have many more accounts in this ledger than what you would typically see in a general ledger.
Thanks, Matt. I was hearing you say a couple of benefits of having an application ledger. And one of those was having the speed for logging a transaction. The other one is making sure that log is accurately attributed. Can you go into a bit more about when companies should consider like building a central ledger to realize these value props?
Sure. Yeah. A lot of companies move money as part of their products. And there's a common journey we've seen amongst a lot of the companies we work with. Most companies tend to start with modeling money on their domain objects. Maybe you're making a ride sharing app. The amount charged for a ride will end up on some ride model. Or if you're starting a food delivery app, maybe the amount charged to your customers is on an order object. This starts to break down as the company becomes bigger. So you might have that financial data spread across a bunch of different databases across different microservices. Some of the data might be in some SaaS products you use. And we have lots of stories about how this is broken down, but a couple really stand out for me. One is in a marketplace payouts company that we talked with. They had a really interesting bug where they are trying to pay out balance to their customers at the end of every day. And there was an interesting edge case where if a transaction came in around the time where they're cutting off the payout, it would get backdated into the payout, but would not actually get included in the money. And this is a great example of how your users have hawk eyes for this kind of thing. Like at the general ledger point of view, you would never notice a $100 payout getting missed, but your customers do notice if even $1 is missing from their expected payout. So that customer wrote in and they realized there was a bug with their ledger. There's a bunch of examples with cards. A lot of companies are offering card programs now because it's a quick way to get your customers access to value that they've stored in your app. So many things have come up. I mentioned speed of getting balances. When you're in the auth path in a card network, you need to respond within just a couple of seconds. And a lot of that will be taken up by other latency within your app. So you need your ledger to be really speedy. So we've had some customers doing live aggregation of their account balances in the auth path, and it starts to time out. Another bug we saw was not reserving funds when a card auth comes through. There's an app out there that if you have two phones, you could probably double spend money. And then another one is explaining to your customer why an auth failed. So there's a really common use case. This tends to happen at gas stations. A gas station will reserve some amount of money on your card, but then that goes away later. And then your customer may have tried to buy a soda at the store, but it was declined. They're really confused because it looks like their available balance would have had enough money, but actually there was this auth taking away that balance for that period. And that's something that you can only go back in history if you have an immutable ledger. One other fun example from a conversation that Koji and I had with a product leader at a leading fintech company that you recognize that we can't name, unfortunately, but he was telling us a story about how at the end of 1 month, a person on the finance team came to his desk and said, "Hey, there's a couple of $1 million missing here." And there was a mad scramble to try to figure out what happened to that money. The really interesting thing is, yeah, the money wasn't gone. It was just the attribution of that money was gone. So it looked like there was a huge hole when in fact everything was fine. So at the end of the day, it's about attribution and using a correct ledger. One analogy I like to make is double entry accounting to unique indexes in a relational database. I know there's a lot of application developers on the call today, and a lot of you probably have had the experience that if you're not enforcing something at the database level, you will have inconsistency. So double entry doesn't solve all your problems, but having that guarantee at the architectural level can really help out and prevent a bunch of edge cases.
Those are really great examples at the architectural level, Matt. I think from the business perspective, where we tend to see a pain is just related to the scale and maturity of companies. So when we talk to startups early on, a lot of those companies can get away with some amount of fudging and doing that kind of last minute reconciliation. and having some amounts between what your users think they have and what cash you actually have be divergent. But the enterprises we work with are often, they can be public or they might be getting ready to go public. They're often working really closely with big banks as partners, and there's a lot less tolerance for that amount of risk. So it's really important that you have a ledger built the right way at that stage. The other thing we often see is that it slows down product velocity when you don't have a ledger built the right way. So we've seen a lot of instances where it takes months after you've actually built, you have a team go out and build an embedded finance product, and it takes a few more months to get it to work with the ledger that you have. So that's really a huge tax on your development team. The flip side is there's a lot of opportunity when you have a ledger built the right way. And we've seen so many cool examples of differentiated products. I think the coolest thing is if you have a single ledger underlying your products, it lets you make those financial products interact seamlessly. So you might start out with a store of value or a closed loop system, but you can add on things like loans or factoring products that read off of that system, or cards that read off the same balances, or you might have different kind of marketplace offerings. And when they play together, you're magnifying the value for your users. Another really cool thing you can do is, especially if you're a big kind of multi-sided marketplace, having a ledger and a closed loop system lets you get capital from the parts of your ecosystem that have it to the parts that don't. So we've seen a lot of cool examples around that as well.
Cool. Thanks. Sounds like there are a lot of new use cases and value props there. And I'm wondering if you could dig deeper into some of the opportunities with the differentiated products you're seeing spun up. Like what kind of innovation are we seeing around closed loop payment systems?
Yeah, this is where we're seeing a lot of cool innovation, especially really the past couple of years. So just as a definition, first of all, a closed loop payment system, the way we're talking about it, is really just a system where money is moving in between users in your network. So you have control over the network. You're not going out to, let's say, like an external card network or something like that, and you're actually facilitating that money movement. And often it includes a digital wallet component. So a store of value, a really typical setup you'll see is you'll have an omnibus, which is, think of that as a pile of cash, and you're subledgering that, meaning your users might have pieces of that, but that's all recorded just on your own database, and you're tracking all those balances. So whether one user has some money or the other has it is entirely up to your database. And often at banks, we'd see that set up with an FBO construct. But closed loop systems in general, it's really cool what we're seeing. I think one of the most famous examples out there is Starbucks and what they've built. Starbucks has been able to drive a really crazy amount of growth through their models, including their Starbucks card. So if you haven't used it, I feel like it's pretty ubiquitous, but if you get the Starbucks app, you can load money onto your Starbucks card and then use it at a Starbucks store. And what that's let them do is they have a couple $2 billion in deposits from that system. And you think about the cash flow implications of that they have a couple $2 billion that users put in, but also users like it. Right? It's fast and delightful. They don't have to go check with a card network when someone comes in to buy something. So it's a great user experience. And the last thing is it gives them a lot of visibility on the payments. They're not offloading onto an external system to process that payment. They're cutting out all the intermediaries and they get to see the full life cycle of that payment. So we see a lot of different payments models. We've worked with companies like Splitwise, Built Rewards, Procore, all these companies that have launched really exciting financial products in the last couple of years and built innovative models. And I think in general, where it gets really interesting is the different kind of nuances and forms of closed loop systems we see built. So what I mean by that is the most simple kind of wallet product you can think of is like something like a Venmo or a Cash App. Right? Put money in, users can pay each other, and then they can pull the money out. But then there are more complex forms that don't look exactly like that. One I'll talk about is a customer of ours, ClassPass. And if you haven't used ClassPass, the way their app works is I can sign up, I pay a monthly subscription, and then every month I get an allocation of ClassPass credits. And I can go into the app, I can find a gym or a studio that I want to book a class at and spend credits to book a class. And they have tens of thousands of studio partners around the world. It looks like a marketplace, but if you look closely at it, it really is a hybrid closed loop system because I'm paying my subscription that turns into ClassPass credits. And now this is all ClassPass credits that they're ledgering and powering the interactions of on the back end. Those credits go to the studio partner, they get converted back into cash, and then the studio partner gets paid out. And that's just one example, but we see so many interesting forms of closed loop payment systems. They can involve like rewards points, gift cards, more traditional stored balances. And a lot of companies are innovating with new models every day. One thing I have to say is I'm not a compliance expert. We work with a lot of experts in the space, but it is important to note that the way you design this closed loop system, it has implications obviously on the user experience, but also on how it's treated in a compliance sense. So it's really important to dive into that as well as you're designing out your closed loop system.
I want to jump in to take one of the questions. Carlos has a good question about designing your ledger. It's saying, can you take a minute to detail more on the structure? I'm assuming, Carlos, you mean how you design the structure of ledger accounts, and how much detail would you recommend? It's hard to make large statements here because it really is on the case-by-case basis. But one common pattern and what's different than a general ledger is you'll have per user sets of accounts rather than just one account for a whole part of your business. So in a past life, I worked on card programs, and I can use that as an example here. In an application ledger, what you'll typically do for a card program, let's say we're designing a ledger transaction for a card off. So the card network is saying, can I charge $20 on this user's account? In a general ledger, you may have one account that represents the total liability that you will owe for all your customers across the debit card program. But in an application ledger, you need to decide, does this user have enough? Not, is there enough in the entire pool of money? So you'll have one account for that user, but then it's double entry, right? So there's also an entry on the asset side for the amount of money that you will pay out to the settlement network at the end of the day. So there will be one account across your whole program. And you get into some interesting technical problems there where there's no contention on the user accounts, but there is on the asset accounts or the one that's shared across your program. But that's one example. We've also seen examples in cards where there's multiple accounts per user. So you might want to categorize spend in different ways, like one's your office expense budget, one's your personal expense budget, for an example. We have a concept then in our Ledger API that lets you group those accounts and show a total balance, but then still attribute transactions to individual accounts there. So the large answer there is it really depends, but it's usually many more accounts on a per user basis. I want to talk a bit about closed loop payment systems in general and where we've seen some complication in ledger design. So if you have a solid application ledger, like Koji mentioned, it's really fast and delightful, both on the user side, but on the developer side to move money, right? It's just a database entry to move the money. Where we've seen a lot of complication and where companies come to us for advice a lot is on the on and off ramps into your closed loop payment system. So how do you get money into the system and then how do eventually users get it out? And what we've noticed is a very common pattern across all these closed loop payment systems is thinking through multiple balances per account. You may, for a given account, we always model a pending balance, a posted balance, and an available balance. This helps you represent real world money movement. So within the closed loop, you can move money from Alice to Bob right away. But if Alice is doing a pay in from her bank account, that's going to take a couple days, but you might want to still represent it on the ledger as a pending credit. And thinking of those different kinds of balances, how do you model money that's expected to come in but hasn't made it yet? Also, when you're outside of your closed loop, you have to start thinking about failure states and get so many questions on this too. In the ledger that we've worked with and what we've seen from customers is they have some concept of archiving. Let's say you tried to ACH debit someone, but it failed because of insufficient funds. You can represent that in a ledger as pending debit that then gets archived when it's not successful. But I think probably a lot of people on the call have worked with ACH before. You can get returns up to 60 days later, and those typically look like they complete and then get reversed. So that's exactly what you do on the ledger too. You say this transaction completed, but then later on we need to reverse it. And the nice thing about tracking everything with double entry is that it's just literally flipping the credits and debits to undo what you did before.
Thanks, Matt. We do have another question from Gaurav. What is a better way to support multi-currency operations through a ledger?
Yeah, I can jump in here and maybe Matt, you'll have an opinion as well. I think two principles we see working well in a lot of setups. Number one is it is important in a double entry ledger to make sure that transaction balances out in both currencies. So let's say you're converting dollars to euros. You can't really have a debit in dollars and a credit in euros and have your ledger balance as a whole. You do want to have accounts that are specifically for the currency conversion and make sure that you're always balanced out in each currency. The other thing is because you have all those kind of entries that are impacting different accounts in your system, it is really important that your design atomically does that entire currency conversion in one go, right? This is really similar to if you're withdrawing money from one user account and putting it in another user's account. You don't want to be able to convert dollars into euros and then not have the euros produced by that action. So those are two high-level principles we see working well in currency conversions.
Thanks, Koji. We have another question from Norman. When making a ledger application, do companies use CQRS and event sourcing? Which database typically gets used?
I am a bit embarrassed to say I'm not familiar with the acronym CQRS, but we have seen companies use different database technologies for their ledger. The most common is just a normal or like an old school relational database. There's something about the entity guarantees that you get in a relational database that makes it really well suited to this problem. But it's not the only kind of database we've seen used. Sometimes companies will use something like Google Spanner or other like auto sharding cloud databases to help manage the scale with mixed results. There's some use case specific ledger databases out there that are optimized for really high throughput. One thing we've noticed from building our ledger is there's different levels of consistency that you need depending on the specific transaction you're writing. So a really common pattern, I've touched on this a bit before, but on a ledger transaction, you may have one that is authorizing the ledger transaction. So if you're doing a card auth, one of the entries on that ledger transaction needs to block. It needs to say, can this happen? And if yes, then it will reserve those funds. But the other entry, which might represent pool of funds that are going to be used in settlement later, that's okay with eventual consistency. So I could talk for this for hours, but how we've designed it on our ledger is you can specify at the entry level whether you need that read after write consistency or it's going to be a high throughput account and you're okay with eventual consistency. And for those eventual consistency use cases where you just need to record that something happened, you can use something like an event bus to process it.
Thanks, Matt. One more question from Paul. We're at the point that we need a general ledger. The interesting part of our use case is using Stripe to update payments straight through on customer accounts /sales ledger and then reconcile with the cash received by Stripe in the bank. But we also receive customer type payments direct to bank, which needs to be reconciled to the customer. Super simplified, but do you feel this type of problem is a good use case?
Yeah, Paul, that's a great question. And this kind of problem is one that we see all the time. And broadly, you're definitely simplifying it because we all know how messy it gets. I'm sure there are a lot of engineering leaders on this call that have seen all the different ways these systems can go wrong. But broadly, a big part of ledgering is also what we talk about being reconciliation. So reconciliation means you do have these external payment systems. Paul, you mentioned Stripe, but you might have a payment processor, and you'll also have your bank. A lot of our customers have bank partners like Goldman or JP Morgan that they're reconciling against. And those external systems are going to do things on their own. And then you have to be able to pull the information from them and reconcile them to the ledger you have internally. And that I would say is one of the hardest parts of building a ledger that communicates with all parts of your system. One principle that we like to think about is it's important to do both transaction and balance reconciliation. So what I mean by that is for every transaction that happens externally, you do often want one transaction in your system, in your application that's reflecting that and staying updated with that external transaction. But also it's important to do balance reconciliation to make sure that the balances in that external processor or wallet or banking system lines up with the balances that your app knows about. And that's a process of reconciliation that I think a lot of the finance folks on the call will be familiar with. And it involves making sure that you have self-healing systems in your application that are able to anomalies and remediate them as well.
Matt, I wonder if you can dig into a little bit what Koji just said about reconciliation and how a central ledger helps with reconciling, especially if you have like double entry.
Yeah, for sure. There's another question that I just saw come in that's related to this too from Depot. Apologies if I pronounced that incorrectly. But how should your ledger support reconciliation, especially when there's variance between your closed loop system versus an external party like a bank? And I've been thinking a lot about this problem, and a lot of our customers come to us with this exact use case. I'd love to hear Koji's thoughts here too. On the one hand, I've heard it described as a fool's errand to compare your internal ledger to an external bank account. But at the same time, every company wants to do this. You need to know, are your inflows going to match your outflows at the end of the day? Or certain kinds of audits require comparing your internal ledger to a bank. So it's a very common problem. I can talk about it from the engineering point of view. This is why we love double entry accounting so much, because the engineers building your financial products need to, whether they know it or not, think about cash reconciliation as they're building the products. One example is a digital wallet. The cash reconciliation is built into the transactions automatically in a digital wallet that's using double entry accounting. For example, we can think of a pay-in. So imagine Alice is getting ACH debited to load $100 onto her digital wallet account. The liability entry on that will be the funds that are attributed to Alice, so that $100. But then there's also an asset entry on that transaction, which represents the account balance in your omnibus. And if you're not using double entry, the engineer doesn't have to think about that omnibus account. But if you are, it's likely that asset account will already match what the bank account balance is. Now, there's lots of complications there. The balances you get from the bank are going to be delayed. They might have a different clock than you. They're not thinking about things in terms of versions, lock versions, strict ordering necessarily, or they might not give you visibility. But you can get pretty close by just implementing double entry in your applications.
Yeah, I think just to add on to that, a lot of the engineering leaders on this call will know that engineers love to think in terms of perfect worlds and perfect systems. And I think that's the way that a lot of application ledgers tend to be built. And there has to be some flex between that and the imperfect payments world that's out there, especially when you're dealing with some of these payment systems that we're talking about or bank systems that are very old. They're going to have different cadences of reporting and they're going to calculate things in different ways. And it's going to be hard to try to make that line up 100% of the time with your internal system, especially second to second, when a lot of these external systems are built on file transfer and things like that. As a broad principle, it's important to make sure your system has some flex between those two parts, between your ledger and the reconciliation with the external reporting. And then you have a good workflow. In our app, we have a kind of UX driven workflow to remediate those problems, to say, okay, there's a gap here, but how do we actually acknowledge and remediate that gap?
Yeah, just one more thing there. There's always going to be a gap, right? But you want to be able to quantify what that gap is and know which transactions you haven't accounted for in either ledger. So that's where the visibility is really important.
Thanks. We have another question from A. When building a general ledger in a young startup, do you have any tips or suggestions on how to properly maintain it as new business processes and flows are introduced?
Yeah, I think in this startup context, there's a few recommendations we'd have. One is, I think where a lot of startups get tripped up is they will often be too opinionated too fast on the objects that they introduce in their system. I think Matt talked about this earlier, but let's say you have a ride sharing app and you create objects in your system that are rides booked and you attach all your flows to that. That makes it really hard later on when you introduce other ways to make payments and other financial flows to make your ledger work with that. So that's a lot of the dead ends that we see companies run into. And even really good companies we see will end up building like 7 or 8 internal ledgers because they have 7 or 8 internal products and they didn't build them in a way that would be interoperable. So interoperability, I think, is really important. And yeah, otherwise, a lot of the architectural principles that Matt mentioned, I think, are important no matter what stage you're at.
How do you suggest handling reconciliation mismatches or failures? This is a question from Nikhil. Also, are there cases when one of the two systems could be lagging with updates?
Yeah, reconciliation mismatches or failures can take a lot of different forms. I think a lot of the time there's the notion of lag. Like sometimes reconciliation won't happen because you have an external system or a bank that tells you later. They tell you a day later or even longer than that when a payment actually moved. I think one really important concept here when you have two systems that are operating at different time scales is you need to have a creation process that runs at a moment in time. It's a lot like the payouts concept that Matt mentioned. Basically, I might say I'm going to reconcile up to yesterday, but that is as of 2:37 p.m. today. And you need to have a system that kind of builds that case and actually records that you did the reconciliation at that moment. The reason I say that is that your ledger also needs the flexibility to be able to say backdate, right? A bank might tell you tomorrow, hey, actually, we had a payment a week ago that we didn't tell you about. And suddenly you said you were reconciled up to yesterday, but it turns out that you weren't. So it's important that I was reconciled up to yesterday at this moment in time. And there's a lot of kind of snapshotting and what we call time machine work that goes into that, which is a big principle that we built into our system. The other thing we built into our system is understanding how these external systems think about timestamps and how those build up into balances so that it gets coordinated with your internal application. And what I mean by that is, for example, if you look at a typical bank setup, a bank will have transactions that go through their system. Let's say you're making ACH payments. Those will show up as transactions, but those get built up into balances that get reported at the end of every day. And it's really important that you understand within their file formats and within their primitives, which timestamp are they using to say that this transaction happened today versus yesterday versus a given moment in time. And your ledger has to reflect that as well so that your balances end up lining up with those external balances. So I think the short answer, Nikhil, to your question is like timing and timestamps are really important. There's always going to be mismatches and failures, but making sure you flag those and making sure that you know when they were resolved is really important.
Thanks, Koji. There's a question from Tripti. We are an early stage startup gearing towards audited financials later this year or early next year. What does our payments product team need to know or build differently to support audited financials?
There's some basic principles that I would suggest you follow. One is use an immutable ledger. So you know about all the money movement that's happening. And when your auditors come look at your money flows, you can say, okay, this was the state on January 1st. This was the state on January 2nd. You can go back and see what the state of every account was at any moment in time. The double entry can really help here too. But we've seen a lot of companies, not startups, but like the common company pathway is to start with a single entry system or money on your domain objects, and then later on hire a recon team that then takes all that data with an ETL, puts it together, and then turns it into some kind of double entry system that then feeds into your ERP. They sometimes suffer from the same garbage in, garbage out problem that you see in AI models, right? It's very difficult to add the double entry data to a single entry ledger. So I'd recommend that you start thinking about double entry from day one so you don't have to do a really costly migration later.
Stat entries to record non-financial, non-GL items, so general ledger items. Is it a best practice to record these daily balances, amounts, or merely month end? Cody, I think we have a
Yeah.
modern treasury view on this, but interested to hear your take.
Yeah. I think one interesting thing about this topic that we're talking about in general is it's really the meeting point of finance and product and tech in an organization. And we end up working with a lot of financial leaders, but also engineering leaders, and they think about this in different ways. Traditionally, finance leaders are going to think about financials and reconciliation, all of that on the month basis or maybe daily basis. But really, at the end of the day, your company probably is a software company and you need it to be able to operate moment to moment. We think it's really important for ledgers to be real time, to be able to produce balances and list transactions in real time. And that's just because if you go into your application, you have a marketplace app or a lending app or whatever, you probably are showing those balances to your users at the moment that they log in. You can't say this was your balance yesterday or a month ago. That's not really acceptable to most users. So in terms of the operation of the ledger, we think it's important to have it be live, but the reconciliation of that against external systems can be daily, or I think monthly isn't ideal, but if you're working with an external system that reports on a monthly basis, then that's what you have to deal with.
Another question from Bipol. Sorry if I mispronounced that. In an application ledger, how do we make sure the balances within our subledger are accurate? The total balance will line up to the total balance in the bank account, but how do we verify the subledger account balance is correct? Is there a better mechanism to make sure our sub accurate, or do we rely on reconciliation to correct the balance if required?
Yeah, I think to some extent, the main protection of reconciliation is going to be, let's say you're subledgering a bank account balance. You really will only have that external bank account balance to reconcile against, and the rest is your ledger's responsibility to figure out. One very basic thing you can do, I know Matt's been evangelizing double entry infrastructure for a while, but really one really important thing to do is make sure that all of those subledger balances, when added up, do add up to the total omnibus balance that you have. So enforcing double entry in your architecture can help do that. Otherwise, I think it's just a lot of the errors come from ops workflows, and it's important to put in the right ops workflows, meaning you might have payments that come in where you have operations or finance folks going in and saying what it should be attributed or allocated to. And it's really up to their judgment which subledger it gets written to. You might say, oh, a $10,000 wire came in and it was a receivable for this user on our platform. It's entirely up to their judgment where it falls in. And there, the way you protect against that going wrong is you put in proper ops protections, like you might have approvals rules or even basic things like permissions on who can log into that workflow and allocate those payments. And that's a lot of internal operational tooling. Again, something that we've had a lot of experience with, but if you decide to build it in-house, it's important that you have all of those protections, or else basically your source of truth is totally at the whims of whoever can log in and allocate those balances.
Just to add onto that a bit, there's some parts of sub-ledger reconciliation that you can automate. Like a very simple check is make sure all the entries written to an account match the balance of that account at any moment in time. They may diverge if you start implementing some caching strategies. So that's something that we've spent quite a lot of time on, making those caches auto-healing and make sure they're always correct. But when you have millions of users, your best auditors are your users. And you just need to give them the tools to do that effectively. So if you're doing payouts, make sure there's a statement that you can give your users with all the transactions that were included in the statement. Make sure that they can see the balance on different days at different times. They can go back and see the history. Give them the tools, and I guarantee you they will tell you when you've done something incorrect.
How do you maintain an immutable ledger? This is from C-Sides, when other systems don't always follow those principles, especially during reconciliation. Things like single transaction, changing amount, or fees from a payment service provider.
There's a lot of different ways to handle this problem, and I've been saying immutable a lot, but actually, if you look at the Ledger API that Modern Treasury provides, a lot of the objects are actually immutable, at least from the point of view of the API. So with the Ledger transaction, for example, if you are modeling a single transaction changing amount or fees, like you might have, I've seen an example where it represented a booking and they would show a pending amount, but as you're going through the flow, that amount might change. And also you don't know, let's say that the taxes until the final submission, but you still want to record it on the ledger during those intermediate steps. In our ledger, what we've done is expose this mutable transaction that becomes immutable once you post it. So there is a moment at which you can't edit it and you must reverse it if you want to change it. But while it's pending, you can still change it. And what we do on the back end is we keep track of the snapshot of every state that transaction went through. We call them ledger transaction versions. So that's one best practice. You can always go back and say, hey, what were all the states that this transaction were in, and what was the pending balance on that transaction at all times? So it has a nice balance between exposing a mutable object in the API that's easy for developers to use, but still keeping track of all the internals. You can always go back and see what it looked like at any point in the past.
Great. And we'll have one last question from Dennis. Imagine you want to categorize the entries to an account, for example, accounts payable, by various tags such as project phase, spending category, vendor. Totals across the account are maintained, but it would be nice to report on the metadata and efficiently report totals on an intersection of those tags. What are your thoughts on how this meshes with ledgering? Koji, you're our product manager. Any thoughts?
Yeah, a few thoughts here. Number one is I talked a little bit about how, as an engineer, you want to think about ledgering in kind of a perfect world scenario, but you have a lot of stakeholders. And I talked about finance, but I think another stakeholder is the data and analytics and reporting teams. And yeah, you also want your ledger to be visible and consumable by them. So if it's too arcane, it's hard for them to understand how do we calculate profitability or user balances for a certain segment, things like that. So I think it's important to tag things. Like you said, you can use things like metadata and tag the transactions that are going into your system. It's also, I think, useful to have those stakeholders able to interact directly with the tables that you're ledgering on. So you don't want those kinds of stakeholders to be able to mutate or edit the ledger in any way, but it is really nice to give them the visibility. One thing that actually our product does is we'll actually push the entire data warehouse version of the ledger to you in a read-only form. And that's one way to give that kind of view to those stakeholders. You also talk about categorization. One principle that we see sometimes and that we have in our system is the notion of account categories. And these are essentially aggregations on top of the accounts. So if you think about an account itself being a aggregation of the entries that are going into your transaction system, a category is an aggregation of those accounts. And it's nice to be able to make those aggregations and to be able to make them in a performant way, because often the different kinds of financial products we see people building will rely not just on a single user's balance to make a decision, but it might rely on multiple balances of that user or multiple balances across users to make a real-time decision. And so it's really important that be cached and accessed properly.
Thank you. Just in closing, do you all have anything else to share? Any recommendations and advice for PMs and engineers tasked with building these payment systems? Any last words?
Yeah, I appreciate everyone jumping on and asking great questions. And I can see in the list, there are a lot of folks from great software companies out there. I would say the fintech market has changed, obviously, in the last couple of years. Companies are less focused on just growing for growth's sake and capturing market share, and more on retaining and driving value to their existing users. And we're especially seeing that with our enterprise users who are trying to monetize and retain their customer base. And in general, I think the best way to do that is always embedded finance. Right? Embedded finance is such a powerful lever for driving value to your users and also cash flow to your company. And so we've worked with companies whose shareholders or investors are pushing for that kind of embedded finance offering. Within embedded finance, closed loop patterns are really powerful. And this is a more recent trend, but it's really powerful if you can create a network with instant, no cost payments within your application, because it's great for users. And also you can build all sorts of financial products on top of it. But I would say we've had different folks to ask questions, some startups. I would say closed loop payments aren't for everyone. You do need a base of users, and not everyone is Starbucks. If you are Starbucks or you have a user base like Starbucks, it's great if you can offer payments to them and do it all within your own network. But I think you have to be careful if you're a smaller company with fewer users, because you do need a critical mass to build out a system like that. Last thing, this is a really rapidly innovating space, and I touched on this earlier, but I do think it's really important to think about what version of this closed loop model you want to go with, and then talk with compliance experts to understand what the implications of that are.
Thanks, Koji. And then on my side, thanks everyone for showing up, asking great questions. I'm super stoked that there was a lot of engineering focused questions too. I'll say it again. I really think it's important for companies that are moving money, regardless of your size, to think about using an immutable and double entry ledger. if you like unique indexes, you'll probably like double entry accounting too. It makes it architecturally impossible to lose track of money. And we've seen a lot of the companies we work with moving into ledgers and seeing benefits in terms of their scale, in terms of correctness. And like Koji said, it really enables you to build some new cool experiences for your customers.
Well, thank you both so much for your insights today. And again, thank you to our audience for joining us. Like I said at the top of the hour, we've recorded the session, so registrants should be able to receive that recording tomorrow, and we'll have it available on our website next week. With that, thanks so much, everybody.